Hi, this is Ferris and this is 6.5 Chemistry. Which of the following are true? All matter is made up of atoms. We know that since we're kids, yani. An electron carries a negative charge. Yeah, the first part is correct, but they're not found inside the nucleus. They move around the nucleus. An object that gains electrons, we just said electrons are negatively charged. So when an object gains electrons, they become negatively charged. Similarly, charged objects attract each other. No, if you get a negative charge and a negative charge, they repel each other. So like charges repel each other, opposite charges attract. All atoms have zero electric charge. Atoms they have a zero charge. Which of the following are true about a conductor? A conductor, it is a material which electric charges can flow. Yeah, that's correct. It can be a metal. Most of the time it's metals. It is a material through which charged particles cannot flow. No, they can flow very easily. It is a state of matter. No, not a conductor. A conductor is not a state of matter, and it is not a phase change either. It's solid, not always solid. You just need to know that it allows charged particles to move between them. Drag and drop the terms from the box to compare the charges of subatomic particles in an atom. So the charge of one proton, protons are positive, the charge of one proton is +1, and neutron, as in the name, neutral, so 0, and electrons are -1. The charge of an atom is 0. As we said, an atom is electrically neutral. Atoms are neutral. They also accept 0 in written spelling. And to find the charge of an ion, you do protons minus electrons. We have 12 protons, 10 electrons, 12 minus 10 plus 2. 17 protons, 18 electrons, minus 1. That's how you get the charge of an ion. See, ions can be positive or negatively charged, but atoms, the charge is 0, they're electrically neutral. Again, to find the charge of an ion, it's protons minus electrons, 19 minus 18. It is +1. The net charge of a nucleus, the nucleus has protons and neutrons. So 19, it's always the charge of the protons, so +19. Nucleus is always the charge of the protons, not electrons, just protons. Check the statements related to the electric model of atoms. We said before they're electrically neutral. Electrons have a charge of -1. Atoms have a tiny central neutron with protons moving around it. This is what they mean about it. Here we have a neutron, and around it the protons. So that's wrong. The nucleus is negatively charged. We just said that the charge of the nucleus is the protons, علشان the neutrons they cancel. They're 0, so it doesn't matter how many neutrons they are. The charge stays the same, so it's the positive charge. The protons have a charge of +1, that's correct. Atoms which gain electrons become negatively charged. We said that's correct. For this section, we've been taking the stuff since grade 5 or even before that, so you should know all of it without me explaining anything. And so this is section 6.4. Which volumetric flask is used to prepare a solution of 0.4 molarity containing 0.2 moles of HCl? So we know C equals N over V, N being 0.2, and we want the volume 0.4, so 0.4x equals 0.2. 0.2 over 0.4 equals 0.5. 0.5 liters, and the options are in milliliter. To convert that, we multiply by 1000. it is 500 millimeter. Consider 1 liter of 0.2 molarity HCl solution. What is the concentration of 0.5 of the HCl solution? They said of the HCl solution. So they're talking about this same solution, which has a 0.2 molarity, and since they're from the same solution, they have the same molarity of 0.2. Now in this quiz, there are two ionic concentration questions. They said that they won't come, so I won't do them. I already did it in the other quiz. And again, if they do say that it is going to come, I will do them. The concentration of saturated solution is called solubility. This is the definition of solubility, you have to memorize that. It is the concentration of a saturated solution. 0.2 moles of magnesium chloride MgL2 is dissolved in 250 milliliters of water. Now, they want the solute. Anything that is getting dissolved is the solute, so here it is magnesium chloride. The molar concentration of the solution is, they want the concentration C equals N over V. N is 0.2, V is 250 milliliters. To convert to liters, we divide by 1000, so 0.25. We put in the calculator, we get 4 over 5 or 0.8 molarity. 70 milliliter of ethanol is mixed with 30 milliliter of water. Circle the solvent. Now most of the time the solvent is the liquid with the greater volume. So here it's 70 milliliter of ethanol and 30 milliliter of water. 70 is greater than 30, so the solvent is ethanol. And for part B, 2 liters of 2.5 molarity ethanol and water solution is prepared in a flask. 250 milliliter of the solution are poured out of the flask into a beaker. What is the concentration of the solution? Now, it is the same solution, only some of it is poured out and some of it is still in the beaker. They want the concentration of the little that's still in the beaker, so it's 2.5. It stays the same solution. 50.0 milliliter of 1.5 molarity HCl solution were poured into a 500 milliliter volumetric flask. Water is added to the etch mark. Okay, we used they want the concentration C1. We use here C1 V1 equals C2 V2. So the concentration at the beginning is 1.5 and the volume is 50 milliliter. So you can't keep it 50 millimeter here because the unit will cancel, but I like converting it back so I don't confuse myself. So it's always liter. 0.05 equals C2, we want that X, and V2 is 500. Again, millimeter, you want them in the same units for 0.5. So you divide, you move the 0.5, so you divide all of this by 0.5. You put it in the calculator. 1.5 times 0.05 over 0.5, you get 0.15 and 0.150 because in the options it's with the 0 at the end. Consider 250 milliliter of 0.5 molarity NaOH solution. The number of moles NaOH found in the solution is, so we know N equals C over CV, and N, the concentration is 0.4, volume is 250 milliliter, we want that into liter, we divide by 1000, so 0.25, we multiply that 0.4 times 0.25, you get 0.1. 8 grams of solute X were required for the preparation of 1 decimeter cubed 0.2 molarity solution. فاحنا we want the moles first. N equals CV. C is 0.2, V is 1, so N is 0.2. Molar mass is grams per mole. So we find the grams, they gave it to us, it's 8 over moles 0.2, and you get 40. You divide 8 by 0.2, you put it in the calculator, you get 40. The molar concentration of a salt solution to molarity is, they want the mass of NaCl to prepare 0.50 liter of this solution. So we find moles. N equals CV, C is 2, V is 0.5, N is 1. You put it in the calculator if you want to check, it's 1. And we know that mass equals N times molar mass. So you have the moles, N times molar mass, NaCl, Na is 23 plus 35.5. You get M equals 1 times 58.5, and the mass is 58.5 grams. What is the molar concentration of 1 decimeter cubed solution, which is 0.5 moles of sodium carbonate is dissolved? We have C equals N over V. N is 0.5, V is 1, so you get 0.5. Two significant figures, so you add a 0. 0.50. For part B, how many moles of sodium carbonate should be dissolved in 0.10 decimeter cubed of water to make a 0.5 molarity solution? So they want the moles, so N equals CV. N equals CV, C is 0.5, V is 0.1. You multiply that into the calculator, you get 1 over 20 or 0.05. 0.05, two significant figures, so you add a 0. They said they want the volume. We know that C equals N over V, so C is 0.2, N is 0.1. They want the Vx, 0.2x equals 0.1. 0.1 divided by 0.2 equals x. 0.1 divided by 0.2, you get 0.5. Again, two significant figures, 0.50. A student wants to prepare 100 centimeter cubed of 0.100 molarity sodium carbonate solution. Find the mass of the sodium carbonate required for this solution. Now sodium carbonate is Na2CO3, Na2CO3, and first we find the moles. N equals CV, C is 0.1, volume is 100 centimeter cubed. We divide that by 1000, so times 0.1. 0.1 times 0.1, it is 0.01. 0.01, and then we know that mass equals Nm for molar mass. We have the moles, so 0.01 times molar mass, 2 times 23, علشان Na2 plus C is 12 plus O3 is 48. You put that in the calculator, you get 0.01, so you get exactly 1.06, and they wanted to 3 significant figures. It's already in the correct amount of significant figures, and that is section 6.4.